In this tutorial video, we're going to show how to calibrate a theta optical tensiometer. The process is also the same for a theta light optical tensiometer. After starting the software, select the sessile drop mode to initialize all the hardware. Make sure the image background is a nice uniform gray color. We'll talk about optimizing your camera settings in another tutorial video. Using the bubble level tool that came with the instrument, make sure the base plate is level by adjusting the feet at the bottom of the instrument. Then make sure that the sample stage is level by adjusting the tilt screws at the bottom. Then place the calibration ball on its magnetic holder so that the ball is directly underneath your needle tip. If the ball is closer or farther away to the camera than the needle tip, then the calibration will not be accurate. As you can see, the ball is out of focus and the magnification could be improved. So the first step is to increase magnification by adjusting the screw closer to the base of the camera lens. The idea is that we want the ball to take up most of the screen, but we also still want to see the surface in our image. Next, we need to adjust the other camera screw, the fine focus, so that it is in the halfway point. This is important so that when we do our fine focusing later on, we don't get stuck by the adjustment bounds. Next is the coarse focusing. Unscrew the screw that is holding the camera in place, then slide it forwards or backwards until the image is in best focus. Then retighten the screw. As you can see, adjusting the screw and doing the coarse focus causes the ball to wobble around in our image. That's okay though, because we'll adjust for it later. Just make sure that the ball is as close to being in focus as you can get it. It's okay if you lose a little bit of focus while tightening the screw again. We can recenter the ball by adjusting the XYZ stage. The manual XYZ stage is shown here. Next, adjust the fine focus so that we can bring the image into best possible focus. We can also right-click to the left or to the right of the calibration ball, right on the edge, and bring up the focus tool. This will allow us to make a better focus. The red line is the brightness, moving from left to right over the point that we right-clicked. The blue line is the derivative of the brightness, and it's the sharpness of our contrast. What we want to do is adjust the fine focus until we maximize the blue peak. Once we're satisfied, we can exit out of the focus tool. Now we're ready to calibrate. Left-click the Calibrated button to the left below the image, make sure Calibration ball is selected, and then hit Calibrate. Notice the blue turquoise line going around the ball. Make sure that that line is going very well around the ball. It's also good if the angle indicators are about 143.1 degrees plus or minus 0.1 degree. If our tip is metal and well defined, we can also calibrate using that. So first let's remove the calibration ball. Then move to the dispenser holder control and lower the dispenser holder until our needle tip is just barely in view in the software. Go back to Calibrated, make sure the needle option is selected, and then enter the outer diameter of the needle in millimeters. For a 22 gauge needle, this is about 0.718 millimeters. When you do this, you'll see a turquoise line appear along the left side of the needle tip. If you're using a hook needle for inverted measurements, make sure that you have the flip Y box selected. The calibration should be repeated whenever you change the magnification of the camera, the FPS setting of the camera, or if you change the distance of the needle tip from the camera. But as you can see, calibration is a pretty fast process, and so I usually do it every day before I start taking data. If I want to check the accuracy of my calibration, I can measure the surface tension of water using the pendant drop method. This value is 72.8 millinewtons per meter. If I don't get this value, it's because the calibration was wrong or my system isn't perfectly clean. To help differentiate whether the calibration is inaccurate or if it's because the system isn't clean, we offer a calibration verification kit. This is essentially a glass slide with silhouettes of standard, pendant, and sessile drop systems. You measure the silhouettes as if it were your sample, and you see whether you got the correct value using your calibration. Hopefully this answered all of your questions concerning calibration, but if you have other questions, please don't hesitate to contact us at Biolin Scientific.